Hello everyone, this is our next video tutorial using Pygames, and we're going to continue on looking at using objects to make sprites move and also using different objects with different methods within our program. Okay, just as a quick recap, this is the template code I've given you. This is obviously available for you to copy and paste and bring in, but it is basically the code we left off with last time. Okay, so if I run it, we should have a very basic game with some sprites, well, randomly generated sprites and a player sprite that you can collect, and you've got a collision, so when you collide with the block objects, you collect them, they disappear, and you get points appearing in the background there, as you can see, and they are disappearing, they're being removed from the screen as we collect them. Okay, so the code we should have here, we created a class here for a block, and that is a sprite class. Okay, we instantiated or initiated it by setting the image, the size of it, and we have a color being created here, and then we create those down here in the further code. We did it within our program here. Look, we've got a loop here to create 50 different blocks that are black and 20 by 15. We randomly place them within the screen and we add them to a list, a block list. We've also got a list of all the sprites that we added to. We also used the same block class to create a player sprite. So we're calling the block class again, but this one is different because it's red, same size, and that. Remember, the player is being added to the all sprite list, but not the block list, so that we can manipulate the blocks separate from the player. Okay. And then within our main loop here, we use the mouse to get the position of the mouse to move the player. And then we've got a collision here, so if the player collides with a block, we finished it off by adding some score at the end. Okay, so that's our basic game so far. So as I said, at the moment, the only movement we've really got in the game is the movement of our mouse. And remember, we are setting the player to the position of the mouse here by going pygame.mouse.getPos, which returns our X and the Y positions of the mouse, and we're separating them out here to set the player rectangle X and the player rectangle Y. So that's the only movement we've really got going on in our game at the moment. The block sprites, the black rectangles, are not moving at all. Now if we want to get the block sprites, the black rectangles, moving as well, we could do very much similar to like we did in the snow drawing tutorial, where we got them falling down the screen. So we could do something simple like for block in block list, which is saying for every block in the block list group that we made, block.rect.y. So basically we're telling it to set the Y property of the block to +1. Okay, that would basically make it fall down the screen, and we should have something a bit like this. The blocks are now falling down the screen just like we had before. Okay, I can still collect them here, but you can see they're falling down the screen, and then they fall off the screen, and that's it. And of course we can reset them to the top and stuff like that. But that's pretty boring. That's, at the moment it's basic and it works. So it works, but we're basically doing a for loop within the main while loop, which is not great. It'd be much better if we could call some way of updating the blocks positions, very similar to the way we draw sprites onto the screen here in one sentence here. So what we're going to do instead is we are going to add a new method to the block class. So I'm going to take this out for a second. Now we know it works, let's just take it out, and we're going to go up to the block class up here. So scroll up until you find your block class, which is, if I can just find it, and here we are. So here's our block class. It's controlling or creating our blocks. So what we're going to do at the moment, all we've got in here at the moment is our constructor method, this initiate one. Okay, we are going to add a new method to it. So tab in, make sure you're inside the block class, and we're going to create a new method. We're going to go def update. So we're going to create a method that updates this block, self, because we're referring to itself. And we're going to basically use the same sort of code we had a second ago. Self.rect.y plus equals 1. So that's basically going to do the same thing we did a moment ago, but we're going to make it reset to the top of the screen, so it's not just going to fall off the bottom of the screen. We're going to go if self.rect.y is bigger than 480, so if it's gone off the bottom of the screen, we're then going to reset the self.rect.y back up to the top again. Okay, 0. So that should put it back at the top of the screen. Okay, so now we've got this method here within our block class. Let's see what happens if we run it. Nothing. At the moment, the blocks are just sat there not moving. Why is that? Have a think. So we've created our method for our class called defUpdate, but at the moment that update method is not being called or run anywhere. So we've got to go now into the main loop, basically where we were a moment ago with this position stuff, and we need to run that method we just created. Now remember, we're calling blocks all the items in the block list, which are the blocks, and then we're going to run the update method. So for every block we have got in the block list, we're now going to update it all in one go. Rather than using a for loop, it'll run every single block in one go. And now if we run it, we're pretty much back to where we were before. The blocks falling down here, however, they pop to the top and appear again at the top of the screen. Now one other thing, can you notice the blocks are like suddenly appearing on the very top here, just like ping, ping, ping on the screen? It would actually be better if the blocks appeared above the screen and then slid down to the screen. So at the moment they're appearing at 0. It'd be better to actually appear them at -20, so then they slide down to the screen. So let's just change that. Let's go back up to our update. Now it's working. Back up to our update. Here it is. So I'm actually going to put in here instead of 0, -20, which is going to make them appear above the top, and it should be nice and smooth now. You see them there sliding onto the screen very nicely. Excellent. So now we've got moving blocks being run from a method of the object rather than being run randomly in our loop. Okay, as we said, now they're appearing at the top of the screen, which is good. However, at the moment, you'll notice we've always got the same pattern. Same pattern of blocks appearing in the same places at the top of the screen. They fall off the bottom and they appear at the same place at the top of the screen. So just like we did with our snowing animation, let's randomize that. So we are moving our Y to the top, but to randomize the pattern, let's go self.rect.x, and we're going to set that to a random location. Well, how do we do that? Random.rand range, so a random number within the range, and our screen width is 640. So that should set a random number within the range of 0 to 640. So randomizing the X location as it's appearing at the top of the screen. And now we should have more randomization within the blocks appearing at the top, so they're not always appearing in the same pattern, which is good. Okay. Okay, that's very well and good to update our blocks, but how about our player? At the moment, if I go down back into the main loop, our player has been updated here. All the code for moving the player is updated within our main loop, which isn't ideal. We want to be able to do other things with the player and things. So it'd be better if we actually had a new class for the player, because remember, the player is a block, but it's not the same as the other blocks. So we can create our own class for a player that inherits the block class. Basically, a player is a special kind of block. So what we're going to do is we're going to go back here, up to where our class is for the block. Underneath our class block, we're going to create another class. So we're going to call this class player. You could have called it anything, but our player is as a suitable name. And inside the brackets here, I'm going to put block. What that's going to do is going to inherit all of the things from our block class here. Inheritance, remember the concept? It's inheriting all the things that a block can do, but as a player. And what we're going to do then, we're actually going to override the update class. Remember, we've got an update property, an update method here for the block, but we don't want the block to be the player to be the same as a block, because at the moment the player will move around. So what we're going to do, we're going to create a new method here for the player called update, and this is going to override the existing one. Okay. So we're going to create a new method here for the player that updates it. And what we're going to do is we're going to take all the code from down here inside our loop now. So all this code for moving the player, I'm going to cut it. And I'm going to put it inside our player. There. Again, make sure it's indented within. So that is now inside our player update class method. Okay, so if I run this now, let's have a look and see what happens. Ooh, there we go. So you'll notice our player now isn't moving at all. In fact, it's stuck in the top corner where it's been created. It's not responding at all. And that is because at the moment, our blocks, the blocks are being updated with the block.update method, but the player isn't included in that because it's not in the blocks list, it's in the all sprites list. So we go back to the code. So if you remember down here in our main loop, we've got this block list update. It's updating the blocks, but it's not updating the player because the player is not in that list. So instead, we're going to change this so it updates all sprites list. It's going to update the list with all the sprites in, including the player, not just the blocks. All sprites list update. So that's going to run the update on all the sprites, including the player. Let's see what happens. Good. The player is moving. However, it's falling down. The player is behaving like a block, like the rest of them. Why is that? Why is the player not responding to the player.update? It's running the block update method instead of the player update method. So let's have a look at our code. Back up here. Look up to where we create the player. Well, at the moment, the player is being created as a block. However, we wanted to create it as a player. Okay, so we want to change it so it's being created as a player instead of a block class object. So down where we create the player, down here, we're going to change this from block to player. So it's going to run the player class instead of the block class, and it will use the player update method rather than the block update method. Now, if I run it, we should have a player block that we can move just like we did before. But now we've got a class for it, for the player, that we can use separate to the block. And we can play to our heart's content here, jumping around the screen, collecting the blocks. So what we've basically just done is changed our code without actually changing anything that's happening in the game. That process is called refactoring. It's improving the code, making it better and more usable, but actually not adding any new usability to it yet. But it is now better with objects in our code. Refactoring. We've refactored the code to have objects instead of putting it in the while loop. Okay, so at the moment our game works. One problem, however, at the moment we collect our objects and as they get to the bottom they do ping back to the top of the screen again. But as we're collecting them, those objects are actually being removed from the game. So as soon as we've collected them all, game is pretty much over. Now that might be the point of your game. It might be to collect 50 objects and game over, done. However, we actually might also want it to do it so that we can keep playing for a certain amount of time instead. So instead, what we're going to do, instead of them disappearing and being removed from the screen forever, we're going to do it so the blocks reset and go back to the top of the screen again. Now we've actually already got the code to reset the position because it's already here. This is the code that resets the position, and at the moment it's being run only when they get to the bottom of the screen. But we actually want to use that also when we collect the blocks. Rather than removing them from the game, we're going to run this code. So what we're going to do is we're going to take this out of here and put it into its own little method. In fact, the only bits we really need to take out are these two lines here. So what we're going to do is I'm going to make a new method here, def for define, reset pos, reset the position of the block, one of the black blocks. Self, because it's referring to itself. I'm going to take out these two lines here, which are doing the resetting, and put them inside our new method there, making sure they're all nicely in line. Remember, this is resetting the Y, and this is randomly positioning the X. Okay. Now, to use that reset method, all I have to do now is run that method within here, self.reset pos. So basically, this update method is going to run this method here. So you're running a method within another method, and you could do that multiple times. You're just running one method within another method in our program. But we can also now use this reset pos in other places in our code just to reset the position whenever we need to. So as I said, at the moment, remember, when a block is being collected or collided with, it's removing it from the game list permanently, and that's it. We're going to go down and find that code down here. Go down until we find the collision code. Here it is. If pygame sprite.collide, we are removing it, and it's this little value here that removes it from the game completely. True. True means remove it from the game. So we're going to set that to false. That will no longer remove it from the game. However, instead of removing it, we need to do something with it. Otherwise, all that will happen is when the code comes up, it will just stay here and our score goes mental. So we need to move it and reset it to the top position instead. So guess what? Now we've got a method we can do here. So as well as adding the score and printing the score, we're going to run our block.reset pos method. So we're going to run the reset position method for the block when it collides with the player. A player collides with a block, doesn't remove it anymore, but it is going to reset its position to the top using the method we've got here. So now, hopefully, when I run this, every time you collect a block, it doesn't work. Hang on. So what's actually happened now then? Now it is actually doing something. If I click on collide with random blocks, it is randomly changing a block and resetting a position. However, it's not resetting the right block. So basically, it is enabled at the moment to detect which block we have collided with. It's just randomly checking it and resetting a block. So what we've got to do instead here is basically check through all the blocks in the list. So instead of an if here, I'm just going to change this little line of code. Now this is getting a bit fiddly and technical now, but just follow along. For block in pygame.sprite.collide, this is going to check for all the blocks. It's going to go through them, and if you've collided, if the player has collided with that block in the list, then it should update the position of that block. So basically we're looping through all the blocks in our list here to check which ones collided, and now it should work. Ding! There we go. So as we collect the blocks, they're not being removed from the game anymore. They are resetting their position to the top of the screen. And now we've got a bit of a game where the faster I collect them, the more they'll respawn at the top of the screen and do that. Okay, so it's almost a bit like a game where I've got to prevent them from falling to the bottom here. And you could turn this into how many points can you get in 30 seconds or whatever like that. Okay, so let's have a quick recap. So today we have taken it from a single class to having two classes now, one for the block and a second player class that extends or inherits the block class, and it's got its own update method. So the player class and the block class have their own update method, and this one overrides the one from the parent class, the block class. So they're both blocks. However, the player is a special kind of block that updates and has got its own properties. And then we run those within the main loop. We run those updates down here, update the whole list, and update both type of lists because all of the blocks are within the list. And we've changed our collision here so that it resets the position by having the method reset pos within the loop. Okay, challenge time. Once you've got this far, can you extend it so that your game does something like this? So that you have a number of lives at the top, and you've basically got to try and stop the lives getting to 0. Let me refresh that one more time. So your life starts at maybe 10, and you've got to try and get them before they get to the bottom of the screen, because every time the blocks touch the bottom of the screen, you lose a life, and the game could stop, game over, when you get to 0 lives, for example. Okay? So to do that, I will give you a bit of a hint. You will need to add a lives attribute to the player, and then change that if the block gets to the bottom of the screen, if one of the block class objects gets to the bottom of the screen. Okay, there's a little challenge. Good luck, and I'll see you in the next video.